Hey guys, in this video we're going to talk about quadratic methods. So we're still talking about factoring, but now we're talking about factoring higher order polynomials. So instead of having just a quadratic, which is polynomial degree 2, we're going to be talking about factoring higher order. So in this case, this is quartic, right? Degree 4. But we're going to be using quadratic methods. So in other words, we're going to be factoring the same way we did when it was quadratic. It's just now higher order than that. So it has to be of a particular form in order for us to do that. And that form is this form we have here. But in a general sense, that's going to be, you're going to have something, it can be any variable. We're used to seeing x. This is y. We're going to used to seeing x. So I'm going to do x. So something times x to a power. I'm going to write the power in a second. Plus something times x to, let's call this the power of n. Plus something else. So if this power is n, any number n, then this power has to be 2n. So simply put, the power here has to be 2 times the power here. So notice this power is 2, this power is 4. It's twice this power. So this power multiplied by 2, right, is 4. So I could have something like 3x to the 6th plus 4x cubed plus 15. I'm just making up these numbers, so this probably isn't actually factorable, but the point is that 3 times 2 is 6. So I can use quadratic methods because this number is twice this number, okay? So it has to follow that pattern in order for us to use quadratic methods. So in this case, we have a 4 here. So when we factor this, we're going to use that the method that we've been using. So quadratic methods. So we're going to figure out something that multiplies to 24 and adds to 10. Is what we're looking for. It multiplies to 24 and adds to 10. So just like we've been doing, right? There's no 1 here, so we don't have to, sorry, there's no leading coefficient, so there's an invisible 1 here, so we don't have to worry about a leading coefficient here. So we don't have to worry about those strategies. We just have to do the plain leading coefficient is 1 kind of factoring. So we're looking for something that multiplies to 24, adds to 10. So we're going to list out our factors of 24 until we find something that adds to 10, just like we've been doing. So that would be 1 and 24, which isn't going to work, but I'm writing it anyway. 2 and 12, also not going to work. 3 and 8. 4 and 6. There we go. 4 and 6. That adds to 10, right? 4 and 6 multiplies to 24 and adds to 10. So that's what we're going to do. So the only difference here, as we're writing this out, usually, okay, if I had just plain x squared plus 10x plus 24, and I found 4 and 6, I would factor that as x plus 4, x plus 6, right? I just have whatever the variable is, I just have that plus one of them, and then the variable plus the other one, and that would be my factored form. But because we don't have a squared here, we have a 4th power. Because we have a 4th power, we just divide this power by 2, or we use this power. Okay, so if you think about it, this power, right, matches this power. So the power of the factors is going to match the power of the middle term. And think of it that way. The power of the factors is going to match the power of the middle term. So in my actual solution for this, instead of having just y, I'm going to have y squared plus 4. And I'm going to have y squared plus 6. Okay? So I have y squared plus 4, y squared plus 6. Okay? So getting my mouse back. This is y squared plus, oops, that's not a plus, that's a times, plus 6 y squared plus 4. And that is our solution. So I'm just going to go to the next question to make sure it's the same form. Okay, yeah, a little bit different. But the concept is exactly the same here. So here, instead of having one variable, and you have this, and then you multiply it by the power by 2, here we have 2 variables. It's going to work exactly the same way, except for now we're going to have a variable in our second term. We're going to have a variable in, so before we had, right, we had y squared squared plus 6, y squared plus 4, right? So in this one, instead of having something squared, we're going to have a c here, and we're going to have a d here. So we're going to have it c plus some number times d. We're still going to look for something that multiplies to 8 and adds to -9. We're still doing that. So again, quadratic methods. So the method stays the same. It's just going to look a little different. So in this case, if we have variables on each side, then on these, we're going to have variables on each side. So our answer is going to take the form of c plus some number, I'm going to call it n, times d, times c plus a different number, probably, times d. And so these are going to be the factors that we found. So some number times d. So there's going to be c in the front and d in the back, because we have c in the front and d in the back. You get it? Okay. So let's do it. So I'm looking for something that multiplies to 8 and adds to -9. Don't forget that negative. So 8, I could have, so I'm looking for something that multiplies to a positive number but adds to a negative number. So both of my factors are going to be negative. Both are going to be negative. So the first one's going to be -1, -8. Oh, look, that adds to -9. I don't have to keep going, because I found something that multiplies to +8 and adds to -9. So remember, they both needed to be negative because they need to multiply to a positive number and add to a negative number. And this is a good example of why you don't forget your factors that include 1, because sometimes they're the one that works. A lot of times this one gets overlooked. You go straight to 2 times 4, something like that, and skip 1 times 8. But 1 times 8 is 8, so we need to account for it. In this case, it's the one that works, so it's important. Okay. So our answer, now that we know what our factors are, our answer is going to be c minus 1d times c minus 8d, right? So our 1 and our -1 and our -8, And they go with the D because that's the second one. Also because that's the one with a number in front of it. There's no number in front of the C, so there shouldn't be any number in front of the C's in our solution. The numbers are in front of the D, so the number should be in front of the D. I can rewrite this without the 1. I don't need the 1, because again, that's just an invisible 1, so I can rewrite that as just C minus D, and then I have C minus 8D is my other solution. So I have these two solutions. I don't have to write the 1 because it's invisible. And I'm going to check my answer and go to the next question.